Question number 6.8. A non-uniform bar of a weight W is suspended at a rest by two string of a negligible weight as shown in a figure. So here it is seen that the rod which is non-uniform, okay, and the angle made by the string with the vertical are 36.9 degree and 53.1 degree, okay. Now the bar is 2 meter long, so we have got the bar is equal to 2 meter long, okay. Calculate the distance deep of the center of the gravity of the bar from its left hand. So this d we want, okay. So this is very easy question, so let us solve it. So first of all we need to draw the free body diagram. So if we draw this rod, so we have drawn the rod like this, okay, and it has been suspended by the string. So string, let us consider it is in this form. There is an string which is at this angle, okay, and there is another string which has another angle. Now see that if you see in the figure, so if you see in the figure, so this angle is how much? Same as 36.9. So we can also consider it as a 37 degree, so it will be better to use and we may get the proper values. And this is 53 degrees, so this is also a 53 degree, okay. This is also a 53 degree, right? So let us put here the values. So we can draw a vertical line here, we can also draw a vertical line here. So this is 37 degree and this is 53 degree, okay. Now let us consider this value is t1 and this value is t2, okay, and there is a certain weight which is at a distance of a t from the left hand side. So this is your w weight, and the distance, this distance is here d, okay. Now can we break tension in the different components? So if you want to break tension in a different component, so let us consider this is as a t cos 37 degree. So before that we need to a shortcut method so that the equation will be very easier. So let us consider this is 37 degree, so this will be 53 degree and this will be 90 degree, okay. So if this is 37 3 degree, if we consider this as a 4, this is a 3, so automatically this will we will get as a 5. So from this figure, so cos 37 degree can be written as base by hypotenuse, that is equal to 4 by 5, and we can also write here uh, sine 37 degree. So sine 37 degree is equal to degree is equal to perpendicular by hypotenuse, that is equal to 3 by 5, right? Okay. Now okay, now here we can see we can say that t or t1 it is your base side, so this will be t1 cos 37 degree. So this will be t1 into 4 by 5 into 4 by 5, or we can directly write 4 by 5 t1, and this is in the form of a sine. See here, this is another component, so we can write easily like sine 37. So this will be t1 3 by 5 t1. Now again we can break this component t2. So here if you break the component t2, so we are getting the t2 as a it is base side. So cos if I want cos 53 degree, so from here cos 53 degree, so cos 53 degree is equal to 3 by 5, and sine 53 degree is equal to 4 by 5. So by using this we will get the equation here. So we can get here t2 cos 53 degree, so cos 53 degree is equal to 3 by 5 t2 here, and this is a sine at 53 degree. So t2 sine 53 degree means what? 4 by 5 T2. Okay, so it is easily understandable now. Now whole body is in equilibrium. Body is in equilibrium. So it means that net net force in horizontal as well as vertical direction, that is fx direction is equal to 0. Sum of force in x direction is equal to, another is your sum of the force in y direction is equal to, and another thing is your sum of moment is equal to 0. Now we will calculate one by one. So if in x direction the sum of the force is 0, so we can consider this that 4 by 5 t2, 4 by 5 t2 minus 3 by 5 t1 is equal to 0. So from here 4 by 5 t2 is equal to 3 by 5 t1, or it will be 4 t2 is equal to 3 t1. Okay, so we can cut from here. So we will get 4 t2 is equal to 3 t1. Okay, so this is one of the equation we have got. Now let us try to find another equation. Another equation is that sum of the force is in y direction. So the y direction total force will be 0. So it is your let us change the color. Okay, and now okay, now let is your 4 by 5 t1. 4 by 5 t1, this force I am talking about, 4 by 5 t1 plus 3 by 5 t2, 3 by 5 t2, and minus w, that is this force, is equal to 0. So from here we have got the another equation. Now third equation is this is second equation. Now the third equation is moment about the moment at any point will be 0. Now for easy purpose we can consider the moment at this point. If we consider moment at this point, so the moment about point A, let us consider this is as a point, this is as a B point, and this is as a C point. So moment about A is equal to 0. Okay, so moment about A is equal to 0. So let us consider now it will be clockwise direction. So let us consider W into A clockwise. If we consider it as a negative, so we can put here negative, and this force will produce this will produce anti-clockwise rotation. So this will be plus 3 by 5 t2 in, and the total distance is how much? Total distance they have given into 2, so this will be equal to 0. Why I have taken, why I haven't talk about this force and this force? Because this force is acting on the line of the action of this point about which we want to find the torque. So the net torque due to this force will be 0. So from here what we have got, we have got this value as a third equation. So our motto should be that by using this three equation we can find the solution. So first equation is your 4, let us change the slide. First equation is 4 t2 is equal to 3 t1. 4 t2 is equal to 3 t1. So this is equation number 1. Now second is your 4 t1, 4 by 5 t1 minus plus 3 by 5 t2. 4 by 5 t1 plus 3 by 5 t2 is equal to w. This is the second equation, and third equation is minus omega a plus 3 by 5 t2 minus omega a plus 3 by 5 t2 into 2 into 2 is equal to 0. Now our main motto, it is not a, why we have, I have written here a, it should be a d distance. Why? Because the distance is d. So let us change this, this will be d only. Okay, so this will be omega d. Our main motto it is to find the d. So here from here we can get the equation w into d is equal to 6 by 5 T2. Okay, now we have to put here the value of W. So the value of W is how much? So this is in the form of T1 and T2. Can we replace the value of T1 and T2? So let us see here. In place of T1, what we can write? 4 by 3 T2. So 4 by 5 into T1. In place of T1, we can write 4 by 3 T2. 4 by 3 T2 plus 3 by 5 T2. This is equal to W. So this will be 16 by 15 T2 plus 9 by 15 T2 is equal to W. So this will be 25 by 15 T2 is equal to W. So from here we can put here the value of omega as, W as 25 by 15 T2 into D is equal to 6 by 5 T2. Okay. So finally, uh, what we are getting? 5 3 ja 15. So T2 will get cancelled out. So D will be equal to 18 by 25. 18 by 25. Um, so how much we will get 18 by 25? So this will be equal to 0.72 meter. So our answer is this one. Okay. So I hope you have understood this question. Got it? Thank you. Now see, this is the question number 6.9 for NCERT. Now here it is given that a car weighs 1800 kgs and the distance between its front and back axle is 1.8 meter. So let us consider this is the center of the front wheel and this is the center of the rear wheel. So the distance between these two is how much? 1.8 meter. And the center of gravity is at is 1.05 meter only. So it may be that there may be the point where the center of gravity this is the center of gravity where weight is acting 1800 kg and the distance of the center of gravity from the rear this front wheel is how much? Distance and its center of gravity is 1.0.5 behind the front axle. So behind the front axle, it means that this is 1.05, right? Determine the force exerted by the level ground on each force. So we need to draw the first of all the free body diagram. So let us consider there is a free body diagram. This is a free body diagram. Okay, and the force which is acting is how much? The force which is acting this force is acting the weight is acting here 1800 kg. So 1800 into 9.8 Newton, this force is acting in downward direction. And as we know that there are two wheels, so there will be a reaction force. So let us consider the reaction force will be at the rear front wheel is Rf, and the reaction force at the back wheel is RR. That is rear wheel. Okay. So this is the thing, and there is no force. We see that there is no force is acting. So here at x is equal to 0, at this point x is equal to 1.05, and at this point the x is equal to 1.8, okay, meter. Now as we know that there is a position of equilibrium position, so what we will do, we will equate sum of f x direction is equal to 0, but in x direction no force is acting. Summation of f in y direction is equal to 0. That means rf plus rr minus 1800 into 9.8 Newton. So this will be equal to 0. So finally we will get Rf plus Rf plus Rr is equal to 176 40 Newton. Okay. Now this is one of the equation. Now as we know that momentum should be also equal to 0. So let us consider moment. We can take the moment at a point in front of front front wheel, near front wheel, where x is equal to 0. So moment about A is equal to 0. If we consider moment about A is equal to 0, so what we have to do? We have to multiply the moment. So the moment due to this is how much? So the moment due to the weight is equal to 1.05 into 1800 uh, 1800 into 9.8 Newton, and minus this will try to move in this direction, and this the reaction force of the back wheel or rear wheel will try to move in anti-clockwise direction. So this sign you may take this as a negative and this as a positive. So it will be r into 1.8, and this will be equal to 0. Now from this we will get rr as equal to as equal to 1.05 into multiplication of this is 17640 divided by 1.8. So the reaction at rear wheel is equal to 1010240 Newton. But there are how many wheels? Two wheels are there. So reaction force on each wheel is equal to 10240 divided by 2 Newton. So this will be how much? This will be equal to, if you divide it, so I think you will get 5145 Newton. So this is the reaction force on each wheel at the rear side. Now we will talk about the front wheel. So we have already got one this equation. So Rf plus Rr is equal to 17640 Newton. So Rf, that is reaction on front wheel, is equal to 17640, and this we can minus subtract this. So this will be 10240. So finally what we will get? We will get 7350 Newton. But we need a reaction force on each wheel. So if we want a reaction force in the front wheel at the each wheel, so we have to divide 7350 by 2. So we will finally get the Newton each 3675 Newton. So this is the answer. Okay, so you have got we have got two answer. So this one and this one. Okay. There is another question. It is a torque of equal magnitudes are applied to a hollow sphere, a hollow cylinder, and a solid sphere. So this is a hollow cylinder and solid sphere. Both are having a same mass and radius. So let us consider torque for sphere is T, a tau, and it has also torque. And it has been told that the mass of the sphere is m and the mass of the cylinder is same, and the sphere as well as they have also given the radius. So r is also same, r is also same. The cylinder is free to rotate about its standard axis of the symmetry. So axis of the symmetry means what? This is the axis of the symmetry. Okay, this is the central axis about which this will be being rotated, and this is for sphere also, this is the axis, central axis about which it will be rotated. So the cylinder is free to rotate about its standard axis of the symmetry, and the sphere is free to rotate about an axis passing through its center. Which one of the following will acquire the greater angular speed? So let us consider. We know that the formula for the torque is equal to formula for the torque is equal to I into alpha. I into alpha. And for this also torque will be equal to I into alpha. I into alpha. But the thing is that both have same torque, right? If both have a same torque, so but the thing is that the inertia for the sphere is how much? Inertia for the sphere is mr square by mr mr square into 2 by 3 or 2 by 3 mr square. But inertia for the cylinder is equal to mr square. So it means that the inertia for the cylinder is more, but the inertia for the sphere is less. So if inertia for the sphere is less, it means that alpha is more. Alpha for sphere is more than the alpha for alpha for the cylinder. So it means that angular speed of sphere is more. Sphere is more. I hope you have understood this question. In this question, they given that the solid cylinder of a mass 20 kg. So the mass of the solid cylinder in this figure, this is the solid cylinder. See here, whole is covered with the mass only. So the mass is how much? Mass is your 20 kg. Okay, and rotates about its axis with an angular. So this is the axis. About this axis, about this axis, it has been rotated. Let us consider this is the axis. Let us consider this is the axis about which it is being rotated. So it is being rotated with the omega. So the value of omega is how much? Value of omega is 100 radian per second. The radius of the cylinder R is 0.25 meter. What is the kinetic energy associated with the rotation of the cylinder? So kinetic energy, we know that the kinetic energy is in the any type of rotation is equal to I by 2 omega square. But the thing is that we have omega but we don't have a I. So first of all we need to find I. So what is the formula for the I? It is a solid cylinder. So I for the solid cylinder. So you should remember this. I for solid cylinder, that is equal to mr square by 2. So if we put here the value of mass, that is equal to 20 into r square means 0.25 whole square divided by 2. So we will get 0.625 kg meter square. So we have got the I. Now we need to find the kinetic energy. So kinetic energy will be equal to how much? This will be equal to 0.625 by 2 into omega square means 100 whole square. So by calculation we can easily get 3125 joule. Okay, I hope you have understood this. So this is the our kinetic energy. Now it is also mentioned in the question that what is the angular momentum. So we know that the angular momentum has a formula L. L is equal to, so this is not a linear, so this is an angular momentum, so L is equal to I into omega. So now we have a value I, so I is equal to 0.625 into omega has a value 100. So finally we will get 62.5 joule second. So this is the this is a angular momentum. So I hope you have got this question right. Thanks for watching this video.